Let's see what's new on the Monster Mill.
Today's video, it's a little bit ad hoc. I didn't really feel like setting everything up, but I've got a friend of mine in Brazil, and what he wanted to do was he wanted to have a panel where he's got his CNC machine, and then he's got physical buttons where he could sit program start, he could hit program stop, he could go jog X left, right, Y up, down, forward, back, Z up and down, and a few other functions. Okay, and that's him down here. We're talking about it right now. And I was like, okay, fine. Well, you've got a printer port, and you've got your CNC set up with a printer port. Printer port's got 5 inputs. All right, so you've got X, Y, and Z home. You've got emergency E-stop, and you've got probe. You're out of pins. You're going to need to add a second printer port, and that's going to give you 5 pins. And if you do program start, program stop, step, pause, you're out of pins as far as the X, Y, Z, or any of that stuff. I said, you're probably going to have to spend $200 and get a Mesa card to get the extra pins. Then I started thinking, joysticks. They got all kinds of joysticks. You got the real fancy ones like this, and you've got some that are like this. Now the ones like this, they've got a bunch of buttons, and if I look at it and break it down, it's basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this one's got 15 buttons on it, and some of them have a little bit more, some of them have a little bit less. And I started thinking, well, if you connect up a joystick, you can actually use it in Linux CNC, because if you plug it in and there's just 1 or 2 little program lines, and I'll show you in a minute, the joystick shows up as an input device, and then under your configuration files it'll have just a whole bunch of data, for each switch, and then you just point that to a function. Like I could take this switch, if it turned out to be input absolute 1, let's say, and I could point it to jog X minus, and when I hit this thing here, the X would jog back. I was like, okay, well, you could buy one of these and break it apart and solder the buttons to it, and that would be pretty cool. Then I got to thinking, I wonder if they make an encoder. If you could just basically buy the joystick without all the plastic. Amazon is your friend. So this is what I found online here, and I'll zoom in here so you can see it. But basically, you can buy these modules, and they're cheap. It's like about $10 US. And so here's one here. Basically, you plug this cable into there, and now you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 buttons, plus a joystick, which is basically another 5 inputs. That's a lot of I/O. And every one of them can be addressable. And that means we can make a physical panel and connect it up. So what I'll do now is I'll just use this one for right now. This is a Wingman joystick, and I'll show you how to find it, how to connect it, how to look at the pins, and then I guess we'll connect up just some jog buttons, and I'll show you how to do that, and that'll be our video for today, and then you can try it and have some fun. And now that he's got me started, I got to order one of these things, because now I want push buttons. Let's go ahead and get this show on the road. I want you to take your joystick and plug your joystick into your machine. Then I want you to open up a terminal like this, and I want you to type in this line. What it's going to do, it's going to pull up a bunch of information, and you're going to see something that looks very similar to this. Now, if you'll notice, the joystick has a name. And what we're going to do is we're going to look at that name for something unique. Like, for example, this one is made by Logitech, but I wouldn't use Logitech because I have a mouse that's made by Logitech, and it would get confused as to which one was which. Also, I wouldn't put Logitech Wingman because then it would try to make two threads, one for Logitech and one for Wingman. So what I'm going to do is just select the Wingman. All right, and that is what we're going to call our joystick. So now what we want to do is we want to open up Axis, and you'll see your regular little screen like this. And then I want you to go up here to Machine, and then I want you to go down to where it says to show the HAL configuration. That's going to give us a lot of important information. It's going to open up like this, and I want you to go to Pins, and you'll see it's going to drop down with some different things in the tree. Find Input and click on it. You're going to see it says 0 because we've got only one source of an input. All right, so now we're going to go ahead and click on that source of input. Now, this is the real meat and potatoes here. These are the names for all the signals that your joystick can produce. So what we need to do is we need to go in and find some things and then verify that what we think they are is actually what they are. See if we can see a change. So let's scroll down to the bottom and we should see something like this. Now your particular joystick may be different, but for mine these signals are down at the bottom. So as you can see, we found an absolute Y is positive. There's also an absolute Y is negative. And if we scroll down a little bit further, you'll see that there's an X is positive and an X is negative, which are the 4 buttons on the top left of my joystick that looks like a little keypad, a little joystick pad. So what we're going to do is we're going to watch those and take a look at it. And to do that, what you need to do is you need to come over here and click on Watch. Then you need to add each one of them to the watch list. All right, so now we have them added to the list, which means that if we start pressing buttons, we should see something happening. So let's go ahead and click on the X positive and the X negative, and we see there's a change. Then the Y positive and the Y negative, and we can see that there's a change there as well. So now we know what buttons are which signals, and we can start adding them into our HAL file. This is the article that I'm following. It's part of the Linux CNC documentation. I'll have a link down in the description so that you can find it, but this is where I'm getting my information from. All right, that and my experience with creating buttons using VYCP and Glade. Now, if you remember on those, we took a button and we, a graphical button, and we connected it up to a signal. We're going to do exactly the same thing, only instead of a graphical button, it's going to be an actual button on the joystick. So let's pull up the HAL file. So we're going to come down here after we open up our custom post GUI HAL, and we're going to come down to line number 8. And we're going to tell it load user and -w HAL input, KRAL, and then there's going to be some joystick name. Now that's going to change depending on what the name of your joystick was. In our example, if you'll remember, mine was a Wingman. So we simply changed that to Wingman, like this. Okay, now the next line, you'll see I've got a set P, and I'm setting the jog speed to 2000. Well, for me, that's 2,000 millimeters per minute, and I've got a little test rig, and I could run it at warp speed, and it's not going to hurt anything. For you, if you're in inches, then put something appropriate for inches, let's say 5 or 10 inches per minute. Millimeters, you might want to go something like 150 or 200 perhaps. But that's going to give you a fixed speed so that when we go pressing these buttons, it's actually going to move. Now, if you've got a Glade panel or if you've got a PYVCP panel and you install a jog speed slider on there, then you don't need it because that's going to replace this line. And then as you slide that slider, you'll pick the actual speed. The trick is if you don't have it, it's like telling somebody to drive to New York at 0 miles an hour. They're never going to get there. So you need to have a speed set. Okay. After that, we're going to start reading from the right to the left. So we take this input 0, absolute X is positive. And we go, okay, if they hit that button, I want you to point to the HAL UI, find jog 0, because 0 is axis X, and the signal plus. And then we just dump that into a variable. We come down to the next one, which is the X is negative. And if so, we apply that to jog 0, 0 being the x-axis, is minus, and that'll push it that way.
And then we can take our next button and do Y, which is axis number 1. And if we were to do Z, that would be axis number 2. And then, you just keep going for A, B, and C axis, depending on how many axes you have. Once you've got that done, you're ready to go. And now we can actually save it, open up the Linux CNC axis, and it should be functional. Well, let's find out. All right, so open up Axis. Let's try it out. Let's push some buttons and see if anything happens. And you see I am getting signals. You can see that in my watch, right? So that's good. Let's go over here and turn the machine on. Now let's push those buttons and see if anything happens. Hey, look, we've got movement. And we can verify that we have the correct buttons to the correct direction. And if everything looks good, hey, we've got it made. We can sit there and drive this thing all over the place now. So that's all there is to connecting the buttons up to the signals to make it do things. And I'm just doing the X and Y jog right now, but you can find other signals in HAL, such as program start, program stop, etc., and you can map those to buttons. And we'll do that more in the next video.